Right, if someone could just very quickly show of hands, verify that you can see my screen. Chapter 4, Speed, Flow and Density. Thank you. Okay, so we're on to then chapter 4, the relationship between or amongst speed, flow and density. So if you look at the brief introduction there, you will see the relationship amongst these elements of speed, flow and density. They're quite important, and the basis of measuring effectiveness, also level of service. It helps you in estimating capacity of your roadway, your facilities. So it's quite important having some understanding uh, amongst these elements of speed, flow and density and how they are related. So the relationship among speed, flow and density. So you can see speed and density relationship, and there's a few points mentioned with regard to speed density relationship. The more important one there is that as your number of cars increase on your road, you will find that it is associated with a decrease in speed, because now you have more vehicles on the road, limit the opportunity for overtaking, and therefore you will find that there's a reduction in speed. And from various studies that have been done, various research, um, generation of models, it was found that there's generally a linear relationship between speed and density. And you will find that where you are obtaining maximum speed, and we use the symbol VF for maximum speed, at that point you would expect zero density, so no queuing of vehicles. Okay? And on the other hand, when your speed is zero, that's when all your vehicles come to a standstill, and that's when you have the maximum density, which we refer to as jam density, DJ. DJ there represents jam density. And we will have a look at these relationships a short while from now when we refer to some of the graphs. Okay. So I'm going to be highlighting for you the key points relating to speed, density, and flow. But however, the onus is on you then to read through the balance of the information that's presented on the slide. So you can see there the speed density relationship equation, and I'm referring to equation 1. That's a linear relationship. So you can calculate the speed at any point on your graph, provided you knew what the maximum speed was, Vf. You knew what the jam density was, the maximum density, and of course the density at that point that you are determining or trying to calculate the speed. So at that point where you're determining the speed, as long as you know the density as well as the maximum speed and the jam density, that's the maximum density, then one could apply this equation and find the speed at any point on the curve. So basically you have three knowns there: maximum speed, jam density, and the density at that point to find the unknown speed at that point. So you can see from the Vs there is your mean speed at that point, space mean speed. We're dealing with space mean speed. Vf is your free speed or maximum speed. Dj is your jam density, and then D is the density at that point that you are calculating the space mean speed Vs. And then we have also the speed flow relationship. That of course was the speed density relationship that we looked at. In terms of the speed flow relationship, firstly, I think you need to highlight the basic or the fundamental association amongst speed, flow, and density. And you can see the basic formula that links speed, flow, and density is that flow is equal to speed times density. So that's a basic fundamental formula. Your space mean speed times your density gives you your flow. In terms of units, you can see that flow is Q. We use Q for flow is equal to V times D. V is your speed, D is your density. Okay, so these formulas that I am highlighting, you should be making a note of them and checking if they're not on your standard data sheet, Annexure A, then you need to know them. So you need to make reference to your data sheet. So basically, if we go through the various factors like the first equation that we looked at, where if you have no flow, the second equation you have no flow, then you are looking at no density. And if one then looked at the equation 1 that we went through a short while ago and the equation 2, the basic fundamental equation, and rearranging that, we can arrive at equation 3. Equation 3, which relates your flow, so that's flow, the Q is equal to dj times Vs minus dj over Vf multiplied by Vs squared. So that's that V there is the speed at that point that you're referring to. And as we said previously, dj is your jam density and Vf is your maximum speed or your free speed. And you can see from here the fact that you have squared, you're now looking at a quadratic equation. And you will see also from the relationship, the figure, the diagram for flow and speed, you will see it's not a linear relationship, it's a quadratic relationship. Okay. So that gives you some details or some information on the flow speed relationship. And then of course, you also have the flow density relationship. So this is the graph that I was referring to. So if you look at the very first graph, that's a relationship between speed and density. And you can see it's a linear relationship. So at that point on the top, that's where you would achieve maximum speed or free speed, Vf. Okay. And when your speed is 0, that point there, when your speed is 0, that's when you would achieve maximum density or jam density dj, that point. So if I had to then look at the flow density relationship, you can see, as I said, because you've looked at the equation, square in your equation, V squared. So you can see from the graph, and once again, at that point where you have zero flow there, zero flow, that means there's no movement, zero flow, all your vehicles are queuing. That's when you would have the maximum vehicles in a queue, which we refer to as your jam density. So there's your jam density at that point. And right on the peak where you achieve maximum flow, Q max is your maximum flow. See, if I had to project down on my horizontal axis, you can see that Q max occurs at half your jam density. There's your dj. So if I took dj over 2, half your jam density, that's where you're achieving maximum flow rate, Q max. Okay, and then if we look at the last graph, which is the speed flow relationship, and you can see that's where you obtain your maximum speed, Vf, free speed. And if you look on your flow graph, at the point at your peak, that's where you achieve your maximum flow, Q max. And you can see again with this graph, where does Q max occur? And if I had to project on my speed line, there I can see that my Q max, my maximum flow rate occurs at half my free speed. That is Vf over 2, half the maximum speed. That is where I achieve my maximum flow rate, Q max. So you can explain these three graphs quite easily, and some of the narrative is given there above, which you can read through. Okay. So moving on, then we have some information on spacing and headways. And to give you a brief explanation or definition of spacing, let's take spacing firstly. You can see from the first few lines that the spacing is simply the distance between successive vehicles. And it's often measured from the front bumper of one vehicle to the next front bumper of the next vehicle, the leading vehicle. Okay, and that distance is your spacing. So your spacing generally is so many meters per vehicle. That's how you would relate your spacing. Whilst headway, the relationship headway is related to time. So it's the time between successive vehicles as they pass a point on your road. As your vehicles pass a point on a road, the time is referred to as your headway. And you may recall at a previous lecture, I did speak about the 3-second rule. So one vehicle passes, 3 seconds later, the next vehicle passes that point. 3 seconds later, the next vehicle passes that point. That is the 3-second rule. And very often traveling at a particular speed, you should be maintaining the 3-second rule so that if the vehicle in front of you stops, you will be able to stop your vehicle. So if your headway is anything less than 3 seconds and the vehicle in front of you stops, you may not be able to stop your vehicle. That could result in a rear end collision. So that is a basic difference between spacing and headway, and we will look at these more in detail when we tackle an example. When we look at an example, and you can see how one can calculate spacing, how one can calculate the headway given the necessary data pertaining to that particular roadway. So again, it's basically analyzing the data. So a bit more information on spacing, density, headway, and some mathematical relationship. And again, if I could go straight down, and you can see from the first line, the mentioning of spacing is the distance measured in meters. So it's meter per vehicle, gives you your spacing, whilst headway is seconds per vehicle, 3 seconds per vehicle. Okay. So one vehicle passes, 3 seconds later, the next vehicle passes. So that's your headway. So note the difference between spacing and headway. So from here, we can see that the relationship between density and spacing. So you can see density is measured in vehicles per kilometer. Yes, per lane, you're dealing with a lane. So density, the main primary unit for density is vehicles per kilometer. So you can see from here, density is basically 1 over the spacing. So your spacing is in meters per vehicle. So if I had to convert meters to kilometers, because my density is in vehicles per kilometer, then simply 1,000 meters is equivalent to a kilometer. And that will then give you density in kilometers, vehicles per kilometer. Okay. And then, so you can see from there the relationship between spacing and density. And then below that in yellow, you have the, okay, I'm not sure why that's not going to certainly a technical problem on Senzela's side that he's unable to connect, so he needs to check his connection. So you can see from there then the relationship now between headway and spacing. So headway, you can see the units for headway, seconds per vehicle. Your spacing was in meters per vehicle. Your speed, if you look at your speed in meters per second, so if I invert from there, you can see, let's just try and see if we can admit 2 of them. So if you go back and check, then your meters will cancel out and the seconds will go onto the top and your units will then be seconds per vehicle, which is your headway in seconds per vehicle. Okay? So it's important knowing these relationships so that when you are given an example, you know exactly. And like I said, although these are the primary units, sometimes the examiner may request the unit to be slightly different. When I say slightly different, instead of meters per second, maybe kilometers per hour. So you should know how to convert from, for example, meters per second to kilometers per hour and so forth. So here you're now looking at on the top the relationship between the flow rate, your flow rate. So you can see now your flow rate, the basic little formula for flow rate or units for flow rate is vehicles per hour. And your flow rate, you can see the relationship with your headway, reciprocal, 1 over your headway is your flow rate. So if you had a headway in seconds per vehicle, and there you got hour, obviously that means you need to convert the seconds to hour, and seconds to hour conversion is 3600. So 3600, and if I invert, vehicle gets to the top, the hour gets to the bottom. That's how we get vehicles per hour. So you can see the relationship there between your flow Q and your headway. Okay. And as mentioned there in the first line or first few lines, given flow rate, the average headway is the reciprocal of the flow rate. And a little example is also given there. So if you had, for example, a flow of 1200 vehicles per hour, then the average headway, they're applying that 3600 over 1200, because your headway was given seconds per vehicle, and you can see from there you get a headway of 3 seconds per vehicle. That's about the average, the 3-second rule that I was referring to. But bear in mind that your headway can change, doesn't have to be 3 seconds, depending a lot, for example, on the flow rate. So with this slide, the only point that I want to highlight here is that several mathematical models have been developed showing you the relationship between flow, speed, density, headway, spacing, and so forth. So various models have been done, various research has been conducted on flow characteristics and with the assistance, and that's how it assists in traffic signals for signalized intersections and so forth. So a lot of research has been carried out, and we will look at some of them, or the main one. And you can see with this slide the traffic stream models. So there are various researchers like Greenshields, he's one of them. There was another mathematician by the name of Greenberg, and a few other green mathematicians that developed these models showing you the relationship between speed, flow, and density, and how they vary with each other. Okay? So don't forget the basic formula there. Q is equal to V times D, the basic formula. And what you're looking at there at the bottom is the relationship that we already looked at between speed and density. So you can see the linear relationship between speed and density. That's where you achieve maximum speed or free speed, mean free speed. And where your speed is 0, at that point you achieve maximum density or DJ, jam density. And again, you can see from this graph midway through where half your free mean speed and half your jam density from the linear relationship. Okay, so that's your speed density relationship. And we've already highlighted the formula that relates flow and speed, And there you have the equation that relates density and speed. So you have the three now: speed with density, flow with density, and then bringing speed into it, density with speed, and flow with speed. So you have the necessary formulae. That's the last one that's reflected there. So the density at any point can be calculated. The density any point can be calculated, provided you knew the speed at that point. The space means speed, and also you knew the free speed or the maximum speed and the maximum density, jam density, dj. And like I said, the best way to demonstrate these equations is to look at an example. So let's go straight onto an example. Before we look at the example, let's look at some of the definitions and some of the relationship and formula, if you were to call it, relating to headway, density, spacing, flow rate, speed, and so forth. So these falls under the characteristics of traffic flow theory. So firstly, if we look at time mean speed, then you all know time mean speed is spot speed, instantaneous speed, what we use for a speed trap device. That's your time mean speed. And it's simply given by the summation of your speed. So if you recorded the speed of 5 vehicles, then summing up the speed of the 5 vehicles divided by 5, n, your number of vehicles, will give you your time mean speed. So if you had 5 vehicles and you recorded the speed of those 5 vehicles, say in meters per second, and you summed up the speed of those 5 vehicles in meters per second and divided by 5 will give you your time mean speed. Space mean speed, you can see, is over a distance. So it's your total distance traveled. So again, if you observed 5 vehicles and vehicle 1 traveled 21 meters in 1 second, so you normally could use, for example, a time-lapse camera. You took a snapshot of a stream of vehicles, and 1 second later, you took another snapshot of that stream of vehicles, and you observed from the gradation on your photos, you observed that vehicle 1 traveled 21 meters in that 1 second, vehicle 2 traveled 19.3 meters, vehicle 3 traveled 18.9 meters, and so forth. You can then sum up the distance traveled by those 5 vehicles divided by the total time in the system. Now, although delta t was 1 second, with 1 second interval, you took the second photo. The total time in the system will be the 1 second multiplied by the number of vehicles. So if you observe 5 vehicles, so it will be 5 times 1 second, giving you 5 seconds. That's your total time in the system. Mean headway, you can see the mean headway then is given by the sum of the time of observation. Sum of time of observation. So depending you're observing, what was the time that you observed, and again it will become more clearer when we look at an example. Sum of the time of the observation. So let's say your sum of the time was x seconds divided by the number of vehicles you're observing. So, and that will give you a headway in so many seconds per vehicle. Remember, your headway is in time, seconds per vehicle. Density, your mean density is given by N over L. N is your number of vehicles. L is the length of your test section. So if you are observing these vehicles over a half a kilometer test section, and you observed 50 vehicles over a half a kilometer test section, then N is 50 divided by half a kilometer, 0.5 kilometers. And from there you can see, you can then work out what is the mean density. Mean spacing, spacing we said was the distance. So it's the distance over a number of vehicles. So depending on the distance, observation distance divided by a number of vehicles. So if the observation distance again was so many meters over the number of vehicles, will give you your mean spacing in meters per vehicle. So units for spacing, meters per vehicle. So again, I'm saying depends what the examiner asks. in terms of units, you will have to abide by the units that the examiner is requesting in a question. And we will look at a question just now. So, and then finally your flow rate Q is the vehicles counted divided by your observation period. So if you counted, say, 100 vehicles divided by your observation period, and that again you could convert to an hour. So your flow rate could be 100 vehicles per hour. If you're converting per hour. Okay, so that's very important to know that. And if you know that, then you can handle a question based on traffic flow theory. And we do have a question. Where are we? I think we skipped something. Yeah, there we go. Skipped a slide there. So there you have a, well, this is just a simple question where you're given, for example, you're given a uniform section of a two-lane, two-way road. And there's your test section reflected, 0.5 kilometer or 500 meters. And you're observing traffic flowing in one lane. And you observed the traffic over a period of 6 minutes. There's your observation period, 6 minutes. And the following data was recorded. So you can see from there you observed 8 vehicles, 1, 2, 3, 4, 5, 6, 7, 8 vehicles. And you set a trap time. So in other words, you set a tubing, you could be a tubing or by synchronized watch, a 20-meter baseline. So 20-meter baseline. So the moment vehicle passed point 1 and point 2, which is 20 meters apart, the time was recorded. And you recorded a time of 1.21 seconds. You can see the units given in second. And similarly, the same for the other vehicle. Vehicle 2 over the 20-meter baseline took 1.01 seconds to traverse that 20-meter baseline. Okay, so this is how typical data could be presented. And from there, then you are required to estimate the following. So firstly, you are required to estimate what the time mean speed is, as well as the space mean speed. And you can see the examiner wants the answer in kilometers per hour. So I'm saying this very, again, it's important, and if you left your answer in meters per second, obviously you're going to lose marks. You haven't answered the full question. So take note of that. The second one, you're required to then estimate the mean headway in seconds per vehicle. So remember, it's your time over N. Your mean density, vehicles per kilometer per lane, in your vehicles over your length. So the density is required in vehicles per kilometer. Your spacing is your distance between your vehicles. So you can see here the spacing in meters per vehicle. And then finally your flow Q in vehicles per hour. Generally the units for flow rate is vehicles per hour. So that's very important for you to highlight the units. So how does one go about solving the question? So firstly, if you go back to the question now, there you're given the time over your 20-meter baseline, which means it's very easy for you to calculate the speed. Speed over the 20-meter baseline, the 20-meter divided by 1.21 seconds will give me my speed in meters per second. Remember, at the stage you need to convert to kilometers per hour. But as it stands from the information given here, if I simply took 20 meters divided by 1.21 seconds, will give me my speed there in meters per second. Second one, 20 meters divided by 1.01 will give me the speed there in meters per second. Okay, I'll give you 2 minutes. Very quickly, get your calculators. You should have some writing material, and very quickly write down for me the speed then in meters per second for vehicle 1, 2, 3, 4, 5, 6, 7, 8. Come 2 minutes. You should do that very quickly. Have the baseline distance. You have your time, seconds. 2 minutes, I'm timing you. All right, you should have computed the speed then. So you can check. Those were the questions that you had to calculate. So step 1, then you computed the speed in meters per second, and you should have arrived at those answers. So check your answers, see if you arrived at those answers. Easy, half a mark each. Okay, so you now have your speed in meters per second. You want to now go back to the question, calculation of time mean speed. Look at the formula. We went through the formula a short while ago. Time mean speed is the sum of your speed divided by a number of vehicles. And you have computed the speed there already. So if you simply add your speed, that's what you are doing. You are adding your speed, the summation of your speed, sum of your speed, divided by a number of vehicles. You observed 8 vehicles, and that gives you a time mean speed of 19.164 meters per second. Go back to the question. The question required you to reflect your speed in kilometers per hour. Multiplying by 3.6 would have given you 68.992 kilometers per hour. That's the time mean speed. And again, note I'm keeping to 3 decimal places. That's what would be required of you in your test and your final exam. And then moving on to the space mean speed. And if you go back to the formula, we did highlight the formula a few slides back. We said the space mean speed is the total distance traveled divided by the total time in the system. So the total distance traveled, you had a 20-meter baseline and you had 8 vehicles. So that will give you the total distance traveled over the total time in the system. Total time in the system that was given to you. So if you go back there to the question, there's your total time in the system. So simply summation of that will give you the total time in the system, and that then gives you space mean speed. Remember, you're looking at meters and seconds, so your answer would be in meters per second, 19.025 meters per second. Converting to kilometers per hour multiplied by 3.6 gives you 68.490. You will notice about mean speed and time mean speed, they're very close. Final speed, you see from the 68.992 and 68.490, close. So here, if you arrived at an answer of say 55 point something, you know you slipped up somewhere in the calculation. Value that you arrive at there should be quite close to the time mean speed, both values, time mean speed and space mean speed. Okay, so you've answered part one then of the question. Then second part of the question was to estimate or calculate the headway. And you know your headway is given by the formula sum of time of observation divided by number of vehicles n. So if you go back to the question now, if you go back to the question, you will see it was given to you there, given to your observation period, 6 minutes. Your observation was over 6 minutes. Okay, so there's your 6 minutes. Now, the 6 minutes converted to seconds multiplied by 60 seconds. So you've now taken care of the seconds divided by a number of vehicles, 8 vehicles, and that works out to 45 seconds per vehicle. So your mean headway worked out to be 45 seconds per vehicle. So go back, you need to go back and check the question. Mean headway in seconds per vehicle, just to make sure that you are conforming to the units that's required of you. All right, that brings us then to the third question, to determine the density. The formula for density is N over L, N being your number of vehicles, L being the length of your test section. Number of vehicles was 8. If you go back to the question was given 500 meters, and in kilometers that's 0.5 kilometers, because you want an answer in vehicles per kilometer. So 8 vehicles divided by 0.5 vehicles per kilometer gives you 16 vehicles per kilometer per lane. So that's your mean density. And then moving on from there to your mean spacing. Your mean spacing then is given by, again, the data sheet that we looked at a short while ago. Mean spacing is given by your observation distance divided by the number of vehicles. Go back to the question, what unit do you want for your mean spacing? And you need the answer in meters per vehicle. So your observation then in meters, half a kilometer, which is 500 meters. There's your value in meters divided by a number of vehicles, 8, and that gives you 62.5 meters per vehicle. So that's your mean spacing. So the front bumper of one vehicle to the front bumper of the next vehicle, leading vehicle, is on average 62.5 meters. Okay. And then finally, you are required then to calculate the flow, and your flow is given by the vehicles counted divided by your observation period. So again, you had 8 vehicles divided by your observation period. Now you need to check your flow, you need your answer in vehicles per hour. Now your observation period was 6 minutes. So 6 minutes divided by 60 will give you hours. Don't forget correct conversion. So that now gives you your units in hours. You got vehicles per hour So if you work that out, 8 divided by 6 over 60, you should get 80 vehicles per hour. So there you have your flow in vehicles per hour. So you can see it's not difficult. What is very important is that you are adhering to the units required. And obviously you need to know the formula for time means speed, space means speed, mean headway, mean density, mean spacing, and your flow rate. Once you know that, then it's simple application of the formula and simply inserting the values in. It's not difficult. Okay. So your second period is your tutorial period. So I'm going to stop at this point. So you have the recording. So this slide will also be on the recording. You will have the recording of this presentation. So for your tutorial period, you can work out this one simple question here where you're given a time-lapse camera that was used to take a snapshot of a stream of traffic 1 second later. So you can see your delta T is 1 second. Second photograph was taken and it was found that the vehicles moved that distance. So you observed 6 vehicles and the vehicles moved that distance in meters. And from the you're looking at distance in meters, so obviously you're looking at space mean speed. So from there, the question said determine the space mean speed in kilometers per hour for the above traffic stream. So that question you would do in your tutorial period that's coming up very shortly. And also, this is not going to take you that long. In your tutorial period, you will also log on to Moodle and look at a question relating to headway, spacing, flow, density, and so forth. There is a question posted on Moodle as well, and you will do that one as well. So that's your tutorial exercise for today. So please work on that. And just 1 or 2 quick announcements before I sign out. Firstly, to say that there is a staff meeting scheduled at noon today, at 12 today. And I think the main agenda item is discussing assessments. So we will have some feedback, hopefully, with regard to admission on campus to write your test. And the other point I want to very quickly mention is that I hope and I trust that you, from your side, have done your bit in terms of ensuring that you are compliant to enter campus. And you all know what's the requirement. I don't have to labor it. It comes from management and you have the relevant sites, portfolios where you read these communications. So you should have done your bit. You should have loaded your information onto the relevant site. And only if your information in terms of COVID compliant was loaded onto the relevant site, then the security department would have issued you an accredited, COVID accredited student card to enter campus. So you should have a student card that says that COVID accredited 2022, which you will then present at the gate to enter campus. Now, if you haven't done your homework and if a test is then scheduled on campus and you send me an email that you are not allowed on campus because you didn't meet the requirement, then unfortunately it's beyond my control. I cannot assist you. You will get 0 for the test. And it's not coming from me again. This is directive and instructions from management, DUT management. So I'm merely conveying to you DUT management's instructions with regard to COVID compliant. So please do your bit so you don't have a problem. And if suddenly we are advised that tests can now be conducted on campus, then who knows, maybe even next week you may have your test one. But like I said, I did inform you or tell you that you should be prepared for your test at short notice. It's supposed to be written on the 15th of March, so you should have been prepared then for the test. Okay, so that's one announcement I want to make. The second announcement I want to make is that next week, Tuesday, I wouldn't be having a lecture on Tuesday. I'm off campus or out of town on official DUT business, so there will be no lectures on next Tuesday. However, we will meet on Thursday. So who knows, after today's meeting, if we are given the green light to write the test on campus, then you may even write the test on Thursday next week. So I'm making you aware of these points well in advance. So I will obviously send you an email and post on Moodle so you are informed. So it could just happen that the test might be scheduled for next Thursday. Failing which, if the situation still stands first week April, then yes, on Tuesday, the 5th of April, you will write the test. That's like the latest date. The earliest date could be next week, Thursday. So have those few points in mind. Take note of those few points and then utilize your tutorial period now, firstly, to tackle this short question and then log on to Moodle and look at a question there. You will find a question there similar to the one we've done, referring to that one, where you are estimating the time mean speed, space mean speed, mean headway, density, spacing, and flow rate. So work on that, work on those two, okay? And yeah, I think that's about it that I want to say for today. So I will keep you posted with regard to the test one. Hopefully something will come out of today's meeting. And yeah, otherwise it would be on Thursday next week that we would meet to continue with Module 4, Traffic Engineering. All right. So let me then stop the recording.